All right, so here we go with evaluating expressions. After this lesson, I would like you to be able to evaluate expressions using given values for the variables. What I want you to understand, though, is later on down the road, you will learn that you can actually substitute an expression in for a variable. So for example, if I have a plus 5 and a is equal to y plus 9, then I can substitute y plus 9 in for the a, so this goes here, and then plus 5. All right, we're not going to work with this large of stuff this time, but I do want you to prepare yourselves for what's coming down the pike at you. All right, today we're just going to talk about how to evaluate expressions using given numbers for our variables. But we have to understand what it means to evaluate. So to evaluate means to calculate the value of an expression. So for example, if I had 4x plus 3y and x equals 2 and y equals 6, then I would substitute the 2 in for the x and the 6 in for the y, and then I would solve. In other words, evaluate the expression. Substitute. When we substitute a number, what's happening is we are replacing a variable with a given equivalent number or expression. Okay, so we're replacing the variable with something else, essentially. So this is where I told you before that if you have, so we have y is equal to 4x minus 1, then that means anywhere that I see y, I can replace it with this expression. This is going to come at you in like 7th or 8th grade. This is what we're focusing on right now, where we're given a value for a variable, and then wherever we see that variable, we substitute in the number. So think about when you're playing a sport. If you're going into the game and somebody else is coming out, it's substitution. So in this case, in this game of math, we have x is coming out and 4 is going in its place. All right, so let's give it a shot. We're going to evaluate each expression for the given value of the variable. So here I have the expression x minus 9 when x is equal to 15. So wherever I see x, I replace it with 15. So if I have x minus 9, I substitute the 15 in for the x. So the x goes out, the 15 goes in. I have 15 minus 9, so that expression would be equivalent to 6. I don't know why I wrote 4, but it's 6. All right, so let's try another one. Here, I have 16, and it's over the n. So what that means here, you have to remember when it looks like a fraction, that means division. So I have 16 divided by n when n is equal to 8. So I keep the 16, I'm still going to divide, but wherever I see the n, I'm going to substitute in an 8. So I have 16 divided by 8, and I know that'll give me 2. So when I evaluate this expression for 8, the answer is 2. All right, so now I have 5/10 times y for y equals 1 4/10. So I have 0 and 5/10, and now I'm going to substitute 1 and 4/10 in for the y. And now I can go ahead and solve. Remember, when I multiply, I want to actually do this off to the side. I shouldn't do it in the middle. Okay, so I can just do 14 times 5. And I know 4 times 5 is 20, carry the 2, 1 times 5 is 5, plus 2 is 7. And then here, this is a decimal and this is a decimal, so there's 1, 2. So I move the decimal 1, 2 places. So it would be 70 hundredths. Don't forget to put that decimal in the front. Here I have 6 times k, where k is equal to 1/3. So I keep my 6, but then I substitute 1/3 in for the k. All right, and I know that I have to turn this into an improper fraction, so it becomes 6 over 1. 6 times 1 is 6. 3 times 1 is 3. And then I know that 6 over 3 is equal to 2. So all I'm doing is I'm substituting the value that I'm given in for the variable that represents it. So I want you to take a minute and I want you to try these problems, and then when you come back, we'll check your answers. All right, so here you should have had 4 times 8, which would give you 32. Here you should have had 6 and 5/10 minus 1 and 8/10. Now notice, I'm going to do the work for this off to the side. I don't do it inside of here. Just like when we talked about order of operations, we're not going to do that. We're going to do any extra work off to the side so we don't get our information mixed up. Bring my decimal straight down. 5 minus 1 is 4, so I should have gotten 4 and 7/10. Here, m is equal to 18, so I substitute 18 in for m over 6, and I know that I get 3. All right. So it's not so bad. Just as long as you remember that if m is equal to 18, I can't substitute in 24 if it's telling me that m has to be 18. I have to substitute in the number that they're giving me for the variable that it goes with. And that's going to make even more sense when we look here, where now we're going to have a couple of problems that have multiple variables. Okay, so down here we're going to especially want to pay attention to our variables and what their values are. All right, so here I have 4 times the quantity x minus 4, where x is equal to 7. So I have 4. I substitute 7 in for the x. I follow my order of operations, and this becomes 4 times 3, which is equal to 12. Now, notice I have 4, and that's times x. It's not on the inside, so I have 4 times 7 minus 4. So now I actually do my multiplication first, and I get 28 minus 4, so I get 24. So it makes a big difference having those parentheses in there, doesn't it? Because here it tells me I need to do the subtraction first, but here it tells me that I need to do the multiplication first. So you need to make sure to take your time and pay attention to what operations you're given and then what order they should be completed in. Now here I have 3 different variables. I have w minus x plus y. So I've been given a value for w, for x, and for y. So I have to be careful to put them in the correct places. So wherever I see w, I'm going to put in a 6. Okay, and you can use different colors to help you out with this to make sure things go in the right place. Wherever I see an x, I'm going to put in a 5. And wherever I see a y, I'm going to put in a 4. All right, so I know what I'm substituting. So w is what I see first, so I'm going to substitute in the 6. And then I keep the subtraction. My next variable is x, and I know that for x, it's equal to 5, so I'm going to substitute in the 5. And then I keep my addition. And then I have y, and my y in this case is equal to 4, so I substitute in the 4, and now I'm going to follow my order of operations. Now remember, addition does not happen first. Addition and subtraction are in the same step, so I subtract first and I get 1, and then I add my 4 to give me 5. Now, if I would have substituted incorrectly and put the 6 in for the x and the 5 in for the w, it would have completely changed my outcome. Here, I'm back to having one variable, but I have that one variable multiple times. So I'm going to substitute 9 in multiple times. So I have x squared, so this becomes 9 squared minus x. So I substitute in 9 again for that x. So even though there's 2 x's, it doesn't matter. I'm still putting in 9 for each of them. Here I have to do the exponent first, so 9 squared is 81 minus 9 gives me 72. All right, what I would like you to do is I'd like you to take a look at these problems. All right, these are going to be on the bottom of one of your pages, and then these are at the top of your next page. All right, and I know that I put the values in the notes. I forgot to add them on here. So let's quick take a look. So notice, like I said, you have these up here, but then you have the other ones on the top of that page. So A equals 3, B equals 4, and C equals 6. And then you guys are going to take your time. So A equals 3, B equals 4, C equals 6. You are going to take your time and you're going to substitute for each of these and then solve. And when you come back, we'll check your answers. So here I should have had 3 times the quantity of 5 plus 1, which would be 3 times 6, which would be 18. Here I would have had 4 times the quantity of 5 minus 4 plus 14. So 4 times 1 plus 14 would be 4 plus 14. And I'm going to go ahead and I'm going to see if I can move these a little bit. Oh, nope, I don't want to do that. All right, so I'm going to have to erase some of this for the time being so I have space to show my work. I should have known better. I write really big. So then here I have 4 plus 14, which is 18. Hey, look at that. I got 18 again. Here I have 6 times 5. Remember, when they're connected, that means multiplication, plus 5 squared. I do the exponent first, so I get 25, because 5 squared means 5 times 5. And then 6 times 5 would be next, which is 30. Plus 25 gives me 55. All right, and then again, remember it's A equals 3, B equals 4, C equals 6. So I have 3 times 4 minus 6, and then I would have 4 times 6 plus 5 times 3. Here I have 3 cubed minus 4 plus 6. And here I get 12 minus 6, which is 6. I have to do my multiplication first from left to right, so I get 24. Now, since this is multiplication and this is multiplication, and they're not connected, like they're connected with addition. Since they're not connected with multiplication, I could do these two steps together, and I would get 24 plus 15, which is 39. Notice I'm boxing all my answers at the end because it makes it easier when you are going through to check your answers. All right, here I have to do parentheses first, so I get 10. So I'm going to have 3 cubed minus 10. Remember, 3 cubed means 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27. Doesn't mean 3 times 3, it means 3 times 3 times 3. And then here, 27 minus 10 is 17. All right, when it comes to word problems, it's not going to be just handed to you like, here's your variable, put this number in. You're going to have to find that important information. So what I'd like you to do is I'd like you to go through and I'd like you to do your ride for all the problems, and then when you come back, we'll check your ride. All right, so here it says find the temperature in degrees Fahrenheit that is equivalent to 30 degrees Celsius. So that's the question. The expression, so this whole thing would be important, gives the temperature in degrees Fahrenheit for a given temperature in degrees Celsius. It's important to note that this is 30 degrees and that it's Celsius. Okay, because if I don't know that this is Celsius or Fahrenheit, I don't know where to plug it in. And then it's also important to note that the temperature in degrees Celsius, C, so that means that C is your temperature in Celsius. So here I'm given the temperature in Celsius, so in my expression, I can replace 30 degrees Celsius with the C, or replace the C with my 30 degrees Celsius. Okay, and actually I'm going to go ahead and solve first and then I'll do the ride next. So here I would have 1 8/10 times 30 plus 32. I know I have to do the 1 8/10 times 30 first, so I know that I can use a calculator here if I want to, but if I'm not going to, I have to do the work off to the side. 8 times 0 is 0, 3 times 8 is 24. I'm done with that, so I add the 0. 0 times 1 is 0, 3 times 1 is 3, so I get 540. Okay, and I have to move my decimal over once because I have one number after the decimal, so this is 54 plus 32. So if it is 30 degrees Celsius outside, that means that it is 86 degrees Fahrenheit. Okay, so it works exactly the same. It's just a matter of finding the pieces to your puzzle inside your expression. Here, the question asks us to find the surface area and the volume of a cube with the side length of 2 meters. It's important to note that it's a cube because we know that cubes have square faces, and squares have all equal sides. So I only need one side length, and that side length is 2 meters. Okay, the expression 6x squared gives the surface area. The expression x cubed gives the volume, where x is the length of one side. Okay, so that's telling you that your x is equal to your side length. And in this case, your side length is equal to 2. So I know that x will be equal to 2 meters. Now when I do the math, I don't put the m in for meters. I just know that my answer at the end has to have the correct label. So to find the surface area, I have to use the correct expression, which is 6 times x squared. So that would mean that I have to do, and I'm going to move it up here because I'm running out of space, 6 times 2 squared, which means I would have to do 6 times 4, which is 24. So that would be 24 meters squared. Okay, because area is always squared, meters squared, units squared. So that's my surface area. And volume, we said, was x cubed. So that means that I have to do 2 cubed, which is equal to 2 times 2 is 4, times 2 is 8. So that's equal to 8 meters. And again, that's cubed because volume is always cubed. And last but not least, so my last question was, how many seconds are there in 7 minutes? So the expression 60 times m gives the number of seconds, so gives the number of seconds in m minutes. How many seconds are there in 7 minutes? Now, you could also have boxed your variables here because those are important numbers, but they're important numbers that are able to be changed. So here, I know m is my variable, and I was told that m represents minutes, and here I'm given 7 minutes, so my variable is going to be equal to 7. So I have 60 times m will give me my number of seconds, which is what I'm looking for. So I'm going to substitute 7 in for m and do 60 times 7. 6 times 7 is 42. Add on the 0 to the end, and my answer is 420 seconds are in 7 minutes. All right, so what you're going to do is you're going to go ahead and do your guided practice. All right, and if you have any questions, please be sure to write them down or email me so we can go over them in class.